Okay, so let's pick up from where we started. So we've done the part A of this problem and part B. Now we're left with part C. So this is going to be a short video, really short one. So part C, what's part C? Prove that 2n minus 1 squared minus 1 is a multiple of 4. Always? I don't know, but if it is, then that's pretty interesting. So let's write down 2n minus 1, 2n minus 1 squared minus 1. Yeah, okay, good. So again, what we do is that we will break the square into multiple terms. The first term is 4n squared minus 4n plus 1 and then minus 1. Okay, so this is the square term. I just get rid of the square by distributing the terms, and now we can get rid of the brackets, right? Minus 4n plus 1 minus 1. And well, because you all know that 1 plus 1 equals to 2 and 1 minus 1 equals to 0, so you probably know what this is. Plus 1 and minus 1 cancels out, and you see we both have a 4 at the front, so probably I'll just factor that. Okay, and similar to the previous strategies, when we have a 2 at the front, there is going to be a factor of 2. So this has a factor of 4, which means it is divisible by 4. And let's see, it is a multiple of 4. A multiple of 4, yeah, just the equivalent meaning over here. So we have proved that it's a multiple of 4, and we're done. Good. So next video, I should be moving on to the complex number properties and some manipulations. Okay. Wait, actually, since I have time in this video, I can also do some simplification of surds. So, right, that's good. Let's make use of the time, huh? So surds, essentially surds are just square root of something. And basically, yeah, okay. So this is a surd. These are surds like square root of AB. Yeah, sort of like that. So we want to simplify the surds. So simplification of surds. So let's quickly do 2 examples. The first one, I want to simplify. So simplify. First part is square root of 20. Now, what we can do is to write it as product, and it's not just any product, but we want one of the factors to be a perfect square. So in this case, 4 times 5 is 20, and 4 is a perfect square. So by the property that square root of a times b is equal to square root of a times square root of b, we can break it down into root 4 times root 5. And root 4, well, we know it's just plus minus 2 times the root of 5. Okay, so technically we need this thing, but I'll just omit it. Okay, so from now on, I'll omit the plus minus just for simplicity. But remember, technically, it should be there. It should be there. Now, the second one, let's see. So, square root of 15 over 48. And how do we do that? So the first thing we do is we reduce the fraction, of course. You see we have a common factor of 3. So this goes to 16, this goes to 5. And then, again, by the property square root of a over b equals to square root of a divided by square root of b, we can break this down into root 5 divided by root of 16. Again, 16 is a perfect square of 4, so we just have a 4 down here, and up in the numerator, the square root of 5, and we're done. And maybe one more, part C. Part C, let me see what examples are on my textbook. Oh, good. Here we go. Square root of 18 times root 2 plus root 3. So, this looks pretty nasty, isn't it? But what we do first is that we simplify this root 18. So, root 18, you can write it in terms of a perfect square. Yeah, and that is 9 times 2 is 18. Times root 2 plus root 3. And then 9 is a perfect square. It's just square root of 9 is 3. Okay, now we distribute the terms. And the first one, root 2 times root 2 is root 2 squared is just 2. And so don't forget to times 3 plus the second term. Root 3 times 3 root 2. Okay, now the first term is 6. And the second one, how should I do this? Let's see. Okay, I will have to combine the two surds, root 3 and root 2, to be square root of 3 times 2. Okay, sorry about my ugly square root sign. Anyways, I'll do it here. 3 times square root of 3 times 2. According to this property, right? We're just doing it the opposite way. We're going from here to here, but it's just the same. And it gives us 6 plus 3 times the root of 6. And yes, that is our simplified version.